All right, so all of these first problems that we're going to do, these are technically what we call prisms, okay? These are all prisms. Now, you specifically have some formulas for prisms. You have a triangular prism, you have a rectangular prism. Technically, a cylinder is a prism. Okay, so the difference between a prism and a pyramid is that a prism has the same bottom and top. It has the same shape on the bottom and the top. Now, the way that they give it to you in the picture, it may not be that clear. So we'll look at that example here in just a second. But all prisms, their volume is the area of the base. We use a big B to denote that, times the height. Okay, now we have to use the big B because the base could be a square, the base could be a rectangle, the base could be a triangle, the base could be a hexagon, the base could be a lot of different things, so that area formula is going to change depending on what figure we're looking at. The height is always just how tall is the figure. Okay, so when you look at the prism formula on your formula sheet for a triangular prism, right there in the middle, it says volume is 1/2 base times height times L. It uses L for the height of the entire thing. But where does the 1/2 base times height come from? That's the area of a triangle. Okay, a rectangular prism, down there in the bottom right corner, its volume is length times width times height. Well, length times width is the area of the rectangle, the area of that base. Now, I give it to you this way because, as I mentioned before, not all the formulas are on here. You may have a shape that has a different base that's not on the formula sheet. If you can find its area, you can find the volume of the prism. All right, so the very first one there is obviously a rectangular prism. Okay, it is a rectangular prism. Let's look at this from the perspective of the area of the base times the height. Now, with a rectangle, you can orient it several different ways. I'm going to say that this right here is my base. So the area of that base is 39 times 12. And we use our calculator. 39 times 12 is 468. That's the area of the base. So the volume is the area of the base times the height. The height is that other dimension that is perpendicular to that base. Okay, the key is it must be perpendicular to the base. So we have a volume of 3,744. We always want to put units on that. So our lengths were in feet. So if we have feet times feet times feet, that is feet cubed. Volume is always in cubic units. Now, obviously, you could have just done length times width times height. Okay, you would have gotten the same answer, 39 times 12 times 8. But I want to do it from this perspective so that we can apply it to any prism. All right, so let's look at that triangular figure over there. So that is obviously a triangular prism. Now, there are a bunch of different measurements on this figure, so you really have to be able to focus in on what's important. Okay, now, you've got to get that this is the base. Now, I know that that's not what it is sitting on. It doesn't have to be sitting on the base. The base is, it has to have the parallel to that has to be the exact same shape, okay? So what I'm saying is if you looked at what it's sitting on a rectangle there, okay, there's not a rectangle that's parallel to that. There's not a duplicate of that rectangle on the bottom. Same thing with the rectangle on the side. There's not a duplicate of that exact same shape. The only shape in this figure that has a duplicate is this triangle that is facing us right here. So if we do the area of that, it's a triangle, so 1/2 times the base is 11, times the height It must be a perpendicular height, so 5.4 is the height of that triangle. So the area of our base is 1/2 times 11 times 5.4. So the area of the base is 29.7. So the volume of our figure is the area of the base times the height. Now we've got 3 different measurements on there that we could choose from as far as what is the height. Well, you got to pick the one that is perpendicular to the base. So this is perpendicular to the base. Now, does anybody notice anything strange about that measurement? Anything strange about that measurement right there? In relation to the other ones? Do those letters mean anything? Inches. Okay, now I'm just going to assume that that's a typo because millimeters is a metric unit, inches is not metric, it's imperial. So those are, we're just going to assume that that's a typo here. Okay, now is it always a typo? No, but if it was inches and feet, then I would say no, it's not a typo. Okay, it's easy to convert inches to feet. But inches and millimeters, not really. So we're just going to go with that. That is a typo there. But 16 is the height of this prism here. So we multiply by the area of the base. So 475.2. And we're going to go with the millimeters here, cubic millimeters. Now, technically, I'm going to go back here to the area of my base and put units on it. Area is in square units. So I'm just going to go back to those 2 pieces since I'm trying to emphasize the units here. All right, questions so far? Anything I need to clarify? All right, let's look at this next figure. What shape is the base of that one? Anybody? What is this? What do we call that shape? Trapezoid. Thank you. I'm not trying to trap y'all. I just want you to participate. This is a trapezoidal prism. Trapezoidal prism right here. So area of a trapezoid. I'm going to write it in general terms before I start to use it, because it's one that we tend to forget. 1/2 times base 1 plus base 2 times the height. Okay. So, all right, where were we at? 1/2 base 1 plus base 2 times h. Okay, so let's focus on the trapezoid because there are a bunch of different numbers on this picture. So base 1 and base 2, those are from the parallel lines. Okay, they are marked as parallel there. It doesn't really matter which one we consider base 1 and which one we consider base 2. I think the obvious one is that 14 is one of our bases. So what's the measurement on the other base? .36. 36 is the measurement on the other base. Now, it's not written on the one that I have highlighted, but it is parallel to that one in the back. It is exactly the same there. So there's 36. The height of the trapezoid, that is that perpendicular distance right there. So that's the 17.9. So let's find the area there. I'm going to use 0.5 instead of 1/2. It's the same thing, right? Okay, so the area of the base is 447.5 square